April 17th, 1945. Belgium. Dawn hadn't yet broken. The sky was smeared with the blue-black sheen of night's final hour, and the tarmac at the 368th Fighter Group's airstrip glistened from a misting drizzle. Somewhere behind the stacked oil drums and hushed hangars, a mechanic cursed under his breath, then slammed the edge of a rusting panel into place. The plane in question wasn't pretty. In fact, most men on base had another name for it. The yard bird. Not in affection. In mockery. It was a P-47 Thunderbolt, or at least what remained of one. The tail was scorched, the canopy slightly misaligned, and one wing bore the patchy remnants of a field repair that looked more like barn work than battlefield-grade maintenance. Rivets mismatched. Ducts protruded where no ducts were designed to. The nose cone had a slight dent that refused to be buffed out. And yet, under that crooked nose, something was different now. Just 48 hours earlier, the plane had been grounded for parts. Its supercharger was failing. Its intake system was misaligned. On any other airfield, it would have been stripped and scrapped. But one mechanic, Sergeant Lou Greaves, saw potential buried in the junk. He didn't have a new intake system. He had a scrapyard. He scavenged pieces of a wrecked Spitfire's ductwork, a crushed auxiliary tank from a downed P-51, and a pressure manifold from a fuel truck that hadn't run since Bastogne. With a welding torch, 2 nights of no sleep, and an almost maniacal stubbornness, he did what no manual ever suggested. He rebuilt the airflow system from scratch, by hand. When the pilots first saw it, they laughed. It looked like a trash can had been strapped to the undercarriage, jagged welds, asymmetrical veins. The exhaust line rerouted in a sharp upward curve. One pilot joked it would fly better if dropped off a cliff. Greaves didn't flinch. He just pointed at the fuselage and said, "She'll climb like nothing you've seen." The next morning, they fueled her up. Pilot Lieutenant Roger Hale, the only man reckless enough to test it, strapped in with a shrug and a smirk. No ceremony, just a nod and a thumbs up from Greaves. At 06:22, the Yardbird took off, or rather, it launched. Witnesses later said the tail barely kissed the runway before it was airborne. Hale pulled hard on the stick and the aircraft didn't stagger or groan. It surged. Climb rate, off the charts. Acceleration, instantaneous. The control tower logged a full 800 feet of vertical gain in just over 2 seconds. At 06:25, Hale radioed back just 3 words. "What the hell?" At 06:29, he spotted a dot on the horizon, fast-moving, high altitude. German jet, an Me-262 on patrol. This wasn't supposed to be a dogfight, not in that plane, not against that enemy. Hale could have disengaged, but something in the stick, in the roar behind him, said otherwise. He climbed. And for the first time since the jets arrived on the Western Front, a piston-engine fighter didn't just match the climb. It overtook it. 3 bursts, 1 kill. When Hale landed, the airfield was silent. No one laughed at the trash can anymore. Because that junkyard upgrade had just turned a grounded relic into the deadliest thing in the sky. And the war would never fly the same again. From the moment the Me-262 first screamed across the European skies, Allied doctrine absorbed one hard truth. Jets couldn't be caught, only avoided. Commanders didn't sugarcoat it. Pilots weren't briefed on how to engage a jet. They were taught how to survive one. The training film said the same thing. If you see one, dive. Don't chase. Don't climb. Get home. The message was clear. The Luftwaffe's jet force wasn't just faster, it was inevitable. No propeller-driven aircraft could touch it in raw speed or climb. And for a while, that fear was earned. The Me-262 boasted a top speed of 540 mph, nearly 150 mph faster than the best American fighters. Its twin Junkers engines gave it staggering acceleration and high-altitude maneuverability. Even its profile, sleek, predatory, ahead of its time, terrified those who saw it. Within weeks of its battlefield debut, bomber crews were calling it the Silver Death. Mustang squadrons learned to spot the blur in the distance and radio warnings in code. Eagle high. That meant break formation, scatter, hope for cloud cover. It didn't help that early encounters were bloodbaths. On October 7th, 1944, a single jet attack over Munster tore apart an entire B-17 element in under 3 minutes. 4 bombers down. 2 Mustangs couldn't close the gap fast enough. The 262s didn't dogfight. They executed. The myth formed fast, and it calcified even faster. You can't outfly a jet. Mechanics believed it. Pilots believed it. Command staff? They leaned into it. Orders came down. Don't engage me 262s unless you have altitude advantage and a miracle. But myths are only as strong as the data they ride on. Lou Greaves didn't buy it. From his position on the ground, fixing blown radiators and warped manifolds, he saw something the others didn't. He kept a log, a crude one, not of kills or sorties, but of jet passes. Every time a returning pilot mentioned seeing a Me-262, Greaves jotted down the timing, the altitude, the angle, and the aftermath. He noticed something odd. The jets were faster, yes, but they had a weakness. They bled speed in turns. Their acceleration flattened out when they maneuvered. Worse, they had a throttle lag, a slight delay between power on and actual response. At high altitude, it was manageable, but lower down, it could be fatal. The problem wasn't power. It was positioning. And in the language of air combat, that's everything. Greaves started talking to pilots, asking questions command staff didn't. What if you could pull up faster? What if you could get your nose under him before he knew? Most dismissed him. But a few, the desperate, the curious, started to listen. The misconception wasn't just about jets being untouchable. It was about piston planes being maxed out, as if engineering had stopped, as if innovation only happened at the factory line. But war doesn't wait for permission. And what Greaves was building in the shadows of a mud-caked Belgian hangar was something dangerously heretical, a quiet rebellion against defeatism. Because what if the real problem wasn't that the jets were too fast? What if it was that the prop planes hadn't been pushed far enough? What if the engine tech still had headroom? What if airflow mattered more than horsepower? And what if, buried in the junk and scrap and field reports, was a way to reverse the myth, not with theory, but with raw, climb-ripping torque? The war was still raging, but a challenge had been laid, not in a strategy meeting, not in a cockpit, but in a welding bay, lit by a single bulb, with a mechanic sketching airflow curves on a metal sheet. Lou Greaves didn't look like a revolutionary. He looked like a grease-stained shadow, sleeves rolled, back bent, hands black with carbon. He wasn't an officer. He didn't carry a sidearm or a clipboard. He carried a wrench, a steel file, and a battered notebook stuffed with flight data no one asked him to collect. Born in rural Indiana, Greaves had grown up fixing tractors, not training in aerodynamics. His education stopped at 12th grade. But when the war broke out, he signed up not to fight, but to keep the planes fighting. Stationed with the 368th Fighter Group, he was one of thousands of ground crew, anonymous, overworked, and expected to follow orders. But Lou didn't follow orders. He asked why. Why were the planes coming back torn up every time the jets showed up? Why did pilots complain about sluggish climb-outs or torque stalls in emergency turns? Why did no one seem to be measuring airflow delta across the supercharger ducts? So he started logging. It began with informal interviews, late-night chats with returning pilots. When did you spot the jet? What angle did he attack from? Did your engine lag when you pulled up? He sketched these stories like battle maps, creating a private archive of inefficiency. Then he turned to the wrecks. Greaves examined the corpses, shot down Mustangs, burnt out Thunderbolts. Not just where they were hit, but how they moved before impact. He traced soot patterns, deformation on engine mounts, even the angle of broken ductwork. He found a pattern, Too much drag on intake systems, inconsistent boost pressure at mid-throttle, airflow choke points that cost precious seconds in climbs. And in air combat, seconds were everything. That's when Greaves got obsessed with the intake system. To most, it was a solved problem. The P-47's turbo supercharger was seen as a mechanical marvel, big, complex, and powerful. But Lou saw it differently. He saw waste, misrouted pressure, turbulence in the airflow that could be redirected, smoothed, accelerated. But no one was listening. So he started building. He found parts wherever he could. Crashed Spitfires, abandoned trucks, a busted Sherman radiator fan that once cut, curved just enough to redirect laminar airflow. He repurposed it as a deflector plate. He welded it into a bent housing salvaged from a fuel tank. It was crude, ugly, but it fit, and it worked, in theory. The only problem was testing. Command didn't authorize experiments, especially not by ground crew. But Greaves knew pilots, reckless, desperate ones. And one of them, Lieutenant Roger Hale, was just crazy enough to try it. Together they chose the worst plane on the field. A barely airworthy P-47 grounded for engine inconsistencies. If it failed, no one would care. If it worked, everything would change. Over 2 nights, Greaves worked under cover of darkness using a tarp and a blackout lantern. The other mechanics joked about the Junkyard project. But Greaves didn't laugh. He was writing a new playbook, not in pencil, but in welded steel. The finished mod looked like hell, but when Hale ran the engine at idle, the RPMs didn't drop. They surged. And when he tested throttle response on the taxi line, it snapped forward like a coiled spring. That was all Greaves needed to know. The airflow wasn't just fixed. It was reborn. He wasn't an engineer. He wasn't an officer. But in that moment, with one hacked-together modification, Lou Greaves became something far more dangerous. A man who proved the system wrong, with nothing but scrap metal, intuition, and a map of airflow drawn in his head. Before Greaves's mod, the numbers painted a grim picture. Between January and March 1945, Luftwaffe jets were responsible for a shocking 38% of all U.S. bomber losses in sectors with jet activity. In some corridors, especially over the Ruhr Valley and western Bavaria, a single squadron of Me-262s could decimate an entire formation in under 6 minutes. Piston engine escorts tried to defend, but the math didn't lie. The P-47 Thunderbolt, America's workhorse, climbed at an average of 3,200 feet per minute under normal boost. The Me-262, over 4,500. Even if a Thunderbolt pilot saw the jet early, he had on average 9.4 seconds to intercept before the German fighter either completed its strike or disappeared into the clouds. That wasn't enough time to gain angle, close the gap, or even stabilize for a burst. Return fire rates in these encounters hovered below 28%. That meant nearly 3/4 of U.S. planes never got a shot off. And kill ratios? Brutal. In the first 60 days of consistent jet activity, piston fighters were losing nearly 3 planes for every Me-262 downed, a 0.31 ratio. Even veteran pilots flew with a sense of futility. Reports frequently included phrases like, "could not catch," "outpaced instantly," or worse, "couldn't even turn to face him." The result wasn't just tactical, it was psychological. Squadrons began to dread jet zones. Briefings included jet evade contingencies as standard. Morale dropped. And some field commanders quietly avoided escorting certain high-risk routes, forcing bomber groups to fly under-defended, and take catastrophic losses as a result. Worse still, command logistics showed the problem escalating. Every downed bomber cost 10 lives and nearly $300,000. Every Thunderbolt lost was another $85,000, not counting training time, fuel, or weaponry. In the first quarter of 1945 alone, jet-caused losses totaled over $28.7 million in equipment. Adjusted for inflation, that's nearly $500 million in today's money. Greaves had seen enough. In his notebook, he began marking what he called no-fire failures. sorties where U.S. fighters never got a clean shot. In one 10-day stretch, 23 planes returned from jet encounters without even discharging their weapons, not because they hesitated, but because they couldn't physically get into position to fight. The problem wasn't courage, it was physics. Greaves focused on one factor: acceleration to climb responsiveness. The lag between throttle input and actual vertical gain. He found the average delay was 2.3 seconds, enough for a jet to gain 700 feet of altitude and vanish. It didn't matter how good the pilot was. The math didn't care. Until one mechanic rewrote it. Greaves's mod, a welded airflow rechanneler built from scrap, changed the intake behavior of the P-47. It didn't give it more horsepower, it gave it faster torque reaction. When the throttle was hit, the engine didn't hesitate. It bit, and with that came one precious thing: time. In early field tests, planes fitted with Greaves's system showed a 2.1-second reduction in climb lag, enough to shave the intercept window from 9.4 seconds to just over 7.3. It still wasn't equal to the Me-262's numbers, but now the gap could be closed. And when the first jet was downed by a modded Thunderbolt, the numbers began to shift. Over the next 12 missions, the upgraded planes achieved a kill ratio of 2.7-1 against jets, not just surviving, but winning. And Greaves's total materials cost? 19.34 hours. Scrap. Welds. Genius. That's when the system started to break. Because the Luftwaffe wasn't facing just prop planes anymore. They were facing physics, redesigned. It wasn't pretty, but it worked. When Sergeant Lou Greaves finally stepped back from his creation, what stared back at him was part war machine, part Frankenstein. The airflow mod wasn't a sleek installation. It was a patchwork of scrap, bent and re-welded around the P-47's intake like an armored tumor. Ducts curved at odd angles. A deflector panel, sawed from an old fuel tank, was riveted in place with bolts salvaged from an artillery crate. The whole thing rattled when the engine coughed. To the rest of the mechanics, it was a joke. "Looks like a metal tumor," one muttered. Greaves didn't argue. He just checked the weld seams and scribbled more notes. He had already mapped the airflow changes, calculated the pressure shifts, and fine-tuned the redirect angle by hand. It wasn't theory anymore. It was built. All he needed was a pilot. Enter Lieutenant Roger Hale, the same lunatic who'd flown a Mustang home with half a wing after taking flak over Metz. If anyone would climb into a machine bolted together from battlefield scrap, it was him. When Hale saw the mod, he didn't laugh. He squinted. "What's it do?" he asked. Greaves replied without blinking. "Saves you 2 seconds." That was all Hale needed. They picked the worst plane in the lot. A limping P-47 that had been grounded after 2 compressor stalls. Command didn't care. If it blew up, they'd just scrap it faster. Greaves worked through the night, torquing bolts, checking pressure seals, soldering in places manuals never mentioned. Hale showed up at dawn, helmet in hand, shrugging off the cold. "You sure it won't kill me?" he asked, half grinning. Greaves didn't smile. "If it does, it'll be fast." At 0641, the engine roared to life. The difference was immediate, not louder, leaner, tighter. The throttle response snapped like a trapped spring. Even on the tarmac, the aircraft jerked forward with less input. Ground crew raised eyebrows. Hale radioed the tower. "We're lit." He wasn't joking. Takeoff was short, just 110 yards. The tail barely lifted before the whole frame surged upward, rising 1,000 feet in 3.4 seconds. Ground control went silent. Then burst. "What the hell was that?" Hale didn't answer. He was climbing. At 7,000 feet, he cut hard right. Testing torque. No stall. Clean. At 10,000, he dropped throttle, then slammed it to full. Testing lag. None. Response was instant. It felt like flying a coiled muscle. He pushed harder, dove, pulled up, rolled. Nothing broke. Nothing choked. Then the call came. A flight of B-26s returning early from a run near Kaiserslautern had picked up an Mi-262. Fast, high, closing in. Hale was nearby. He didn't hesitate. Throttle full. Climb angle 38 degrees. The altimeter spun. The jet spotted him too late. Hale hit the intercept window fast. Too fast for the Mi-262 to peel cleanly. The German tried to dive away. Bad choice. With the new airflow, the P-47 didn't just keep pace. It matched descent and angle. Hale rolled into firing position, fired a burst. Smoke. The jet lurched. Another burst. Kill confirmed. He returned to base at 071 Skeeks. When he landed, no one spoke. Not at first. Then one mechanic whispered, "He killed a jet? With that?" That was all it took. Within 24 hours, Greaves had 6 more mod requests. Within 48, 12 planes had been retrofitted. The brass hadn't signed off. Didn't matter. In war, results rewrite regulations. And one Junkyard upgrade had just changed the battlefield math. Not in theory, but in fire and metal and speed. By the end of day 2, Greaves's so-called trash mod had spread across the base like wildfire. Not because it was approved, because it worked. Pilots who once sneered at the crude welds were now lining up to fly modded birds. Word spread beyond the 368th. Ground crews from nearby squadrons began showing up with sketches, measurements, and bolt kits, begging Greaves for a template. He didn't have one. Every build was custom fit, adjusted by eye and airflow feedback. But the principle held. The system had flipped. The plane that once barely cleared tree lines was now hitting altitudes it had never seen, and doing it faster than engineers thought possible. Here's what changed. 1. Climb rate. Modded P-47s went from 3,200 feet min to over 4,100 feet min at emergency power, a 28% increase. Not by changing the engine, but by eliminating the lag in airflow that had throttled performance. That narrowed the vertical gap with Mi-262s by nearly half. 2. Intercept time. Time to angle dropped from 9.4 seconds to 6.8. That meant U.S. pilots could now turn, climb, and engage before a jet vanished, opening windows for a shot that had previously been closed before it even began. 3. Energy bleed. By smoothing the airflow, pilots could execute tighter climbs and dives without losing RPM stability, crucial when pushing the engine near redline. It didn't stop there. German intel picked up the shift. Intercepts of Luftwaffe radio traffic showed an uptick in terms like fast props and climbing threats. One recorded message translated as, "Avoid prolonged attack over sector G6. New climb angle observed." In simpler terms, they were scared. By the end of the first week, 9 jets had been confirmed downed by Greaves' modded Thunderbolts. Kill ratios flipped, 3.11. And of those, 5 were shot from below, a direction jets had never expected threat from. The math of dominance had reversed. Meanwhile, commanders scrambled to catch up. Field reports contradicted Central Command assumptions. They still believed prop planes couldn't keep up. But the kill log said otherwise. And when Brass finally visited the 368th, what they found shocked them. Planes that looked like scrap metal, flying like missiles. The collapse wasn't just in the sky, it was in the doctrine. Doctrine said, wait for replacement jets. Greaves proved, no need. Doctrine said it takes months to retrofit. Greaves proved, $19, 36 hours. Doctrine said this war would be won by industry. Greaves proved it could be won by one man with a torch. At first they tried to slow him down, demanded paperwork, approval chains, engineering sign-offs. But the front line didn't wait. Because when a mod lets you outclimb a Mi-262, no one cares what the manual says. Pilots started pushing harder, testing, flying directly at jets instead of away. Reports came back of enemy craft breaking off first, retreating. The Luftwaffe's advantage, speed and fear, was crumbling, and the most brutal number of all, 0. That's how many pilots in Greaves's modded planes were lost in jet engagements during the first 2 weeks of deployment. 0. Not one went down. It wasn't just a weapon now. It was a doctrine breaker. And somewhere in a Belgian hangar, Greaves kept welding. Not for fame, not for rank, but because the math was finally on their side. April 25th, 1945. Sky over Dusseldorf, 21,000 feet. Lieutenant Hank Morris flew like a man with nothing to lose. And today, he flew the Yard Bird. Not a Yard Bird, the Yard Bird. The very first modded P-47, the one Greaves had welded into legend. It had racked up 2 confirmed kills in 3 sorties, still ugly, still crooked, but pilots whispered about it like it was Excalibur with a propeller. Morris had flown her before. He trusted her. He just didn't expect what he'd face next. At 14:16, Mission Command relayed an incoming blip, fast, high, and closing, probably a recon jet, maybe a patrol. What showed up was worse. 2 Me-262s, silver streaks slicing through contrails. No hesitation, no warning. They dove straight for the lead bomber flight. A cluster of B-26 Marauders returning from a strike on a chemical plant east of Essen. The escort Mustangs peeled to intercept. But Morris didn't wait. He punched throttle. The mod kicked. The Yardbird surged. From 18,000 to 21,000 in under 11 seconds. The climb arced like a slingshot. The Me-262s weren't ready for it. No prop plane ever climbed into them. Morris used the shock, closed fast. The first jet passed so close he saw the pilot's goggles flash. He rolled, fell in behind the second jet, tracking tight. The 262 banked hard. Normally this was escape, but Morris held angle. The mod kept airflow smooth through the turn. No stall, no delay, just speed. He squeezed the trigger. Short burst. Sparks. Hit on the port engine. The jet veered left, smoke trailing, altitude bleeding. Morris followed. Another burst. The canopy blew. The pilot ejected. 1 kill. But he wasn't done. The first jet reappeared, trying to loop behind. Morris yanked the stick. Normally suicidal, but the Yardbird's mod didn't choke. It spun sharp. The German pilot overcorrected. They spiraled head-on. Both pilots fired. Morris's rounds hit first. The Me-262 snapped sideways mid-air, tail shredded. It exploded in a roll, fireball in the sky. Morris dove through the debris cloud, heart hammering. 2 jets, 71 seconds. He climbed again, scanned for more. Nothing. The radio cracked. Thunderbolt 5 status? Morris exhaled. 2 down. Still flying. He landed to silence. Not shock. Reverence. Command reviewed the gun camera footage twice, then once more. They didn't believe it at first. 2 jets, 1 plane, no backup. And when they asked what gave him the edge, Morris answered in 2 words. Greaves Weld. From that day forward, every pilot who flew a modded Thunderbolt demanded the Yardbird's layout. They wanted the angles, the weld lengths, even the bolt patterns, because the dogfight over Dusseldorf proved something no doctrine ever dared claim. You could beat a jet, not with better speed, with better design. May 2nd, 1945. The war was days from ending, but no one told the Luftwaffe. Over the skies of southern Germany, remnants of elite squadrons were still active, desperate to slow the Allied push into Bavaria. On this day, a flight of 4 P-47s from the 368th was assigned a routine recon escort over Augsburg. No heavy resistance expected, just a flyover. Then the ambush came. 2 Me-262s dropped from the sun. Classic bounce. High speed, high angle. The American formation scattered, 2 Thunderbolts diving, 1 banking hard left. The 4th, piloted by Lieutenant Dave Carter, climbed. That alone shocked the Germans. Carter's plane wasn't just another Thunderbolt. It was a Greaves-modded Deep Claw variant. Same airflow upgrade, but further refined. This one had tighter curvature on the intake diffuser and a new cowling shroud that redirected pressure even during high G turns. On paper, it meant nothing. In air, it meant everything. The lead 262 spotted Carter's move and responded with a textbook reversal. Dive, roll under, then climb back into position. Every training manual said this maneuver ended with the jet above and the prop fighter smoked. But Carter didn't follow the manual. As the jet rolled, Carter dropped throttle. Not to slow down, but to rotate tighter. The mod caught the airflow, kept the engine breathing. No power stall, no torque drag. He turned under the roll. A maneuver so tight it defied the aircraft's factory specs. He was now behind the jet. The German pilot banked, shocked. He punched throttle. Flames streaked from the engines, but Carter was already locked in. His first burst ripped into the fuselage. The second set it ablaze. Jet down. The second 262 tried to disengage, diving at full speed. Carter followed, not straight, not fast, smart. He cut through a cloud layer, predicted the path, and popped out ahead. Another burst. Second kill. This wasn't luck. This was the first documented reverse turn. An impossibly tight climb-and-roll maneuver enabled not by horsepower, but by airflow responsiveness. Carter later said, "It felt like the air moved out of my way." Command couldn't believe it. They reviewed the telemetry. Carter had pulled 6.1 Gs in that reversal without engine stall. No one thought that was possible. Engineers checked the welds, still intact. Greaves was called in for questioning. Instead, they gave him a commendation. From that moment, every pilot wanted the reverse turn spec. Within 2 weeks, 31 more P-47s were flying with the Deep Claw variant, and jet kills doubled. They never found a blueprint. No diagrams, no official draft, no factory approval. What Lou Greaves built wasn't from a lab or think tank. It was made from bent metal, torch heat, and instinct. And that's what terrified the engineers most, because what he created worked. Not once, not twice, but across dozens of combat tests, under fire, against the most advanced aerial weapons Nazi Germany could produce. While Allied command debated theoretical jet counters in boardrooms, one mechanic rewrote air combat physics on the back of a radiator shroud. His mod didn't just work, it humiliated expectations. In total, Greaves's airflow modification was installed in 37 P-47 Thunderbolts before VE Day. Those planes recorded a combined kill ratio of 3.41 against Me-262s and other jets, nearly 10 times the average for standard P-47s. But more than the kills, it was the absence of death that mattered. Not a single pilot flying a fully modded Greaves system was lost in a jet engagement during that period. 0. That number traveled faster than any plane. Suddenly, factory engineers wanted to study the system. Logistics officers drafted memos asking for standardization procedures. Command staff, who once dismissed the whole thing as field improvisation, now called it adaptive design doctrine. But Greaves didn't care. He wasn't chasing glory. He didn't want rank. He wanted planes to come back home, intact. That's why the final image of him on May 7, 1945, the day before the surrender, is so haunting. No medals, no speeches, just a man with a blowtorch, hunched over a sheet of scavenged aluminum, scribbling airflow curves in chalk while engines roared in the background. He didn't need a blueprint, because he was the blueprint. The Luftwaffe collapsed. The jets vanished. The war ended. But for a brief window in the dying days of World War II, a handful of American fighters, armed not with new engines but with better airflow, tore apart one of the most terrifying myths in aviation history. And they did it because one mechanic refused to believe that good enough meant the end. When the War Museum finally displayed the Yardbird, they asked Greaves what inscription they should use on the plaque. He said 6 words. Wasn't supposed to fly, did anyway. They called him a mechanic. But Lou Greaves was an engineer of necessity, a physicist without a diploma, and a battlefield designer with nothing but scrap and nerve. What he built didn't just save planes. It reshaped what pilots believed was possible. From $19 in junk metal came the answer to a $5 million threat. From one blueprint etched in chalk came a doctrine that would haunt engineers for decades. It's easy to forget, in an age of satellites and stealth, that wars are not always won by tech giants or generals. Sometimes it's a man on the floor of a hangar, welding with frostbitten hands, who makes the math work again. And when his pilots soared past 30,000 feet, when his jet's killers turned impossible turns into easy climbs, when enemy aces called retreat before the dogfight even began, they knew. This wasn't luck. This wasn't theory. This was a war machine reborn by one man's refusal to accept defeat. Because the next war is never announced in headlines. It starts with a plane stalling, and it ends with one that climbs anyway.